Welcome to the Explainer. Go ahead and settle in, get comfortable. Today, we're taking a journey into the messy, real-world process of fixing an open source bug. And I don't mean the perfectly polished version you see in a quick 10-minute tutorial. We're talking about the authentic version, the one with false starts, absolutely frustrating terminal errors, and that sinking feeling in your gut when you genuinely think you've broken someone else's codebase. So, we're going to walk step by step through a real Rust contribution, pulling apart exactly what it actually takes to earn that coveted merged badge. Now, if you've ever stared at a GitHub repository and filtered by the good first issue label, you know exactly how intimidating it can be. But here's a little secret for you. Sometimes those issues come with the solution already written out. In the exact case we're looking at today, the maintainer had actually diagnosed the bug, written the exact fix, and even listed the test cases. Your first reaction might be a bit of suspicion, right? Like, why didn't they just fix it themselves? Well, writing a diagnosis is not the same as implementing it. Maintainers use these deeply detailed issues as scaffolding for your learning, not as a spoiler. They're deliberately stepping back to let a new contributor step up and grow. Section 1. A good first issue. So, the project at the center of our explainer today is called Toolport. You can think of it as a sort of traffic control system for AI tools. It manages Model Context Protocol, or MCP servers, basically ensuring different services can talk to each other seamlessly. The bug itself lived in a really small, super approachable file called vendors.rs, all confined within a single function. It was small enough to be digestible, but real enough to actually matter in production. Okay, let's break down exactly what was going wrong here. The function in that vendors file was trying to figure out which company's server a URL belonged to, say GitHub or Stripe. It did this by checking if a specific keyword appeared anywhere in the URL string. And I mean literally anywhere. Take a look at this Composo server URL we have here, mcp.composo.dev/GitHub. Because the code was blindly searching for the word GitHub across the entire string, it spotted the path at the very end and confidently declared, yep, this is a GitHub server. Wrong vendor. And because of that, completely wrong instructions were being shown to the user. And here is why this mattered immensely. Let's look at another vendor, Clerk. Clerk's entry had a special flag telling the app that it didn't need an authentication token to connect. So when a Composo URL with /clerk in the path got completely misclassified as a Clerk server, users were essentially told, hey, just connect, no token needed. The result? The connection would fail silently at runtime. This wasn't just some tiny cosmetic glitch. It was actively misleading users at the exact moment they needed accurate information. Section 2. The setup struggle. Actually writing the code is rarely the hardest part. The real battle? The environment setup. Before a single line of Rust was even typed, there was this absolute gauntlet of chaotic setup struggles. First off, completely missing node.js on the machine, then accidentally running npm install in the home directory instead of the project folder, which is a classic, deeply humbling mistake where your system just throws its hands up looking for a package.json file. And finally, accidentally triggering a massive 40-minute build of node from source because of a flaky network fallback. These aren't just annoying detours from real open source work. Honestly, this is the work. And after finally wrestling with Node, simply running cargo test caused another massive roadblock. The project used Tori, which is a framework for building desktop apps, and that requires the GTK graphical toolkit installed right at the operating system level. Now, our little fix had absolutely zero to do with graphical interfaces, but cargo test doesn't care. It compiles the whole shebang. That meant downloading and installing 456 operating system packages. Yep, 456, all just to run a test on 6 lines of basic logic. The friction definitely didn't stop there. A super heavy cargo build was running at the exact same time the Rust analyzer was trying to index the project in the background. Those two processes absolutely choked the PC, just fighting for RAM and freezing VS Code completely. Add to that a sudden cold wave of panic when you realize you're making your edits directly on the main branch. But hey, a quick note to ease any beginner's fears out there. Editing on main is perfectly harmless as long as you haven't committed yet. A simple git checkout -b followed by your new branch name completely saves the day. Section 3. Anatomy of the fix. The true elegance of this fix is all in the details. Step 1 is URL: parse. This takes the raw, messy text string and gives it structure, breaking it cleanly into its scheme, host, and path. Step 2 is .ok? Since parsing can fail, this safely converts the result into an option, and that little question mark smoothly short-circuits the function if it fails, meaning no crashing, just a clean, quiet exit. Step 3 is .host_string? This extracts only the hostname, like mcp.composio.dev. Step 4 normalizes all of that to lowercase. And finally, step 5, we search for the vendor's keyword strictly within that extracted host. This brilliantly illustrates the paradigm shift we needed. You've got the old, buggy behavior, which was searching the entire URL string, accidentally catching keywords hiding way down in the file paths. Contrast that with the new, elegant solution, searching only the host domain. The absolute crucial takeaway here is that the real trick wasn't changing what to search for, it was simply narrowing down where to search. Now, you might be wondering, why not just change the keyword? Why not search for github.com instead of just GitHub? Well, consider these real-world examples to see why that tempting wrong turn would have been disastrous. Revenue Cat's real server lives at .ai, not .com, and GitHub's Copilot endpoint is api.githubcopilot.com. If we had tightened our keywords to exact .com domains, we would have instantly broken real, legitimate vendor detection across the board. The loose keyword was literally never the problem. The scope of the search was. Section 4. Learning from tests. Writing the test for this fix ended up involving 3 highly educational mistakes. First, in Rust, isNone is a method, which means it needs parentheses to actually be called. Without them, you just get hit with a compiler error. Second, writing a test URL without the https:// scheme. Without a scheme, the URL parser instantly fails and completely crashes the test. And third, guessing the case of the vendor name as lowercase GitHub instead of the exact byte-by-byte capitalization of capital G, capital H, GitHub used in the source code. The big lesson here? Always grep before you guess. Look at the actual source code. Do not rely on your memory. And this leads us to a pretty profound realization. A good test should fail on the old code and pass on the new code. I know it sounds super obvious, but it's absolutely crucial. If a test passes vacuously by accident on the old code, it isn't actually testing anything real. You need that contrast. You literally need to prove that the old logic explicitly fails the scenario your new logic so elegantly handles. Section 5, Open Source Takeaways. So, the tests finally pass. The PR is pushed. And then, checking back a little bit later, our contributor experiences a massive plot twist. The issue was already marked closed. For a heart-stopping minute, it genuinely looked like someone else had beaten them to the punch. But looking a little closer, the PR was actually merged under their own username. The maintainer had swiftly reviewed, approved, and merged the code right into the main project. The maintainer even left an incredibly glowing piece of feedback. They wrote, "You took the exact steer from the issue and resisted the tempting wrong turn, which was tightening the needles into full domains. Matching on the host is the right fix." Guys, this is exactly what makes the struggle worth it. It proves how incredibly rewarding, clear, properly scoped open source contributions can be when you take the time to deeply understand a problem rather than just rushing to slap a patch on it. So what should we really take away from this explainer? First, environment setup is the real work. Please don't let toolchain friction make you feel like you're failing. It happens to everyone. Second, use detailed issues as scaffolding to understand the underlying architecture, not just as spoilers to copy-paste. Third, don't try to improve things beyond the specific scope of the bug. The narrow, disciplined fix is usually the most sophisticated one. And finally, grep before you guess. Always verify exact strings and types right in the source code itself. Ultimately, it was just a few lines of Rust, but the process of earning those lines teaches you more about real-world software engineering than 100 tutorials ever could. Which leaves me with one final question for you. Armed with this structured approach, what is your first open source fix going to be? Take a breath, go find that good first issue tag, and just start building. Thanks so much for joining me on this explainer, and I'll catch you next time.